All right, so you've probably heard of ozone. You probably heard that there's a hole in our ozone with regard to the Earth's atmosphere, and we'll talk about that. But ozone is a molecule, and it has 3 oxygen atoms that are stuck together. And ozone, O3, can naturally form by taking regular oxygen, O2, and combining it with kind of a miscellaneous oxygen atom. There's good ozone, and actually this kind of famous ozone hole is in our good ozone layer. The good ozone is located in a layer of the Earth's atmosphere we call the stratosphere. And here in a part coming up, I'm going to actually in Chapter 1 talk about layers of the Earth's atmosphere. And the stratosphere is the second layer of the Earth's atmosphere going up kind of horizontally. So the good ozone is located in the stratosphere. And the reason it's good is actually it blocks, it's good at blocking incoming particular wavelength of light from the sun called ultraviolet. Ultraviolet radiation or ultraviolet light from the sun can be blocked with the presence of O3 in the stratosphere. So if you've ever, when you buy sunblock, which hopefully you've bought sunblock before, but it will tell you what sort of protection you can expect from that lotion with regard to blocking ultraviolet radiation. The problem with ultraviolet radiation is that ultraviolet radiation has been known to, I think this is right, you can get skin cancer from ultraviolet radiation. It makes abnormalities in your cells. So the thing about the ozone hole in the good layer of the ozone in the stratosphere has to do with the presence of CFCs. And CFC stands for chlorofluorocarbons. And in the past, chlorofluorocarbons have been used as propellants, like as in hairspray, it was the Fs that carried the stuff you wanted to put on your hair. CFCs in the past have also been used as refrigerants and puffing agents. So our ozone layer in the stratosphere has been compromised by CFCs. I have a slide coming up to explain that actually we have curbed greatly on Earth the use of CFCs. Now the bad ozone, if that's not bad enough, I don't know if you've ever seen one of these little photos, or a photo of if you've been driving down the interstate and you see a sign here, I don't know if you can read it, it says ozone alert, and it gives the date. So bad ozone is located here in this layer of the Earth's atmosphere called the troposphere. And we'll be talking more about bad ozone in the section, Unit 5, I believe, when we talk about pollution. But bad ozone is formed in the troposphere, and it's formed because of human activity. Often linked, I think most primarily, O3 is linked to burning of fossil fuels. It's a type of photochemical smog. So bad ozone, by the way, the reason we have these alerts like this is if you have any sort of kind of breathing disorder, but like asthma, or you've just bad ozone, or O3 in the troposphere actually can make it difficult to breathe. So let's talk about the ozone hole, shall we? I have a few slides to kind of talk about the ozone hole. This says again that O3 is compromised or can be broken down by chlorofluorocarbons. And in 1987, I would say worldwide, folks got together, part of the United Nations, and agreed to curb our use of chlorofluorocarbons. And so it's going to take, I think, 100 years or so for the O3 molecules in the stratosphere, that ozone layer, to replenish itself, but it is doing so over time. It's hopefully repairing itself. So just to kind of show you, I got this, see what you think, I got this off the internet. So here we have an O3 molecule, and it's being attacked by a CFC molecule. The CFC is here. Let's see, yeah, this is the CFC. Okay, and this is the O3, and this would be the ozone layer in the stratosphere. Okay, this just kind of shows you step by step what happens. Notice we have ultraviolet radiation will break off a chlorine atom here. That free chlorine then will attack an O3. Okay, and then you end up, you don't have your O3 anymore. You don't have your ozone. That can protect incoming ultraviolet radiation. And kind of the net result, what you're seeing here finish up, is that it can actually, that little chlorine, that free chlorine atom that kind of started up here, okay, it can be released to do it again. So there you go. So when we talk about the ozone hole, there's some kind of interesting things you might want to know. So we count on the good ozone layer, the good O3 layer in the stratosphere as being complete. The holes occur seasonally over the polar regions. If I had a globe between my hands, this would be the North Pole and this would be the South Pole. That's where the holes occur, and they're seasonal. And I'll kind of talk you through why they're seasonal. So here we go. And actually, I believe the first hole was found in the southern hemisphere over Antarctica. The hole and it's not really a hole, it's just kind of a thinning of the O3 layer seasonally. And then later we do now know that there is a hole in the good ozone layer in the stratosphere over the northern hemisphere, over the North Pole too. But why they occur and why they occur seasonally actually has to do, as I've read, by a special type of cloud called a polar stratospheric cloud. Polar stratospheric clouds can occur only under very, very cold conditions. Polar stratospheric clouds occur in the stratosphere, and they only occur at the polar regions. So here's the deal. When it is in the dead of winter, basically the conditions are such that we have, let's go in the southern hemisphere. In the dead of winter in the southern hemisphere, those clouds, polar stratospheric clouds, are definitely there. Okay. Now, one thing about the polar stratospheric clouds is that they are good at tying up kind of random chlorofluorocarbons. They're good at tying up kind of those random chlorine atoms. Now, as those CLs, those chlorine atoms, or the chlorofluorocarbon molecules are kind of tied up in the clouds, they can't go around breaking O3 molecules. But what happens then during the springtime in that hemisphere, in this case the southern hemisphere, when spring comes, what happens is that those clouds start to break up or dissipate. And so then kind of all at once we have a release of the free chlorines and of the chlorofluorocarbons molecules all at once. And so they tend to go ahead and scavenge and find, it's like they're not smart, they're not doing this on purpose, but they will go ahead and react with ozone, the good ozone. And so kind of in the springtime, all at once you'll have a thinning of that ozone layer in that hemisphere. Okay, so it's seasonal, and it's located where we have polar stratospheric clouds. Okay? Yeah. So as I've been talking the Antarctic, the springtime there would be September, October, versus the springtime here, of course, would be March, April. So I've got some figures to show you. This is, let's see, and I looked and looked to make sure I'm trying to kind of explain this correctly. What you're looking at is, notice this is how thick the O3 is. So this, the more red, the better. The more blue or purple, the worse. Okay? So actually, the way you read this is, and I don't know if you can kind of see the trace outline, this is Antarctica. Okay? So as you read this, actually, in the year 2010, we are looking at less '03 than we were in 1979. So there has been, as I understand it, a delay in kind of the replenishing of our ozone over Antarctica. And kind of along those lines, this is showing you what is the extent of the ozone hole. And here and over here we have years 1980 to 2015, which hasn't happened yet. Okay, but the ozone hole, you can see, has had some dips, but it has overall kind of gone up. Okay, ozone hole decreased here, looks like 2003, then increased 2004, decreased in 2005, and so right now over here we're starting to kind of maybe hopefully see kind of a decrease in the ozone hole. Again, it's seasonal when that hemisphere is experiencing spring. But how big is the hole? Well, here, this square kilometers is the area basically of North America. So this might look a little bit cheerier for you. Here we're looking at, this would be the hole over, again, at the southern hemisphere. And you can see the kind of seasonal nature of the hole. And here, this red one is in '06, and the blue one is in 2010. So they peak about the same time, kind of the thinning of the '03 in the stratosphere. But you can see that